Any clue? Otherwise, I'm going to have to go to the uh, I'm going to have to go to my screen. Any thoughts?
Sue, can you hear me?
Ah, I found it. Never mind. I've got it.
Perfect. Thanks.
Okay. This is this should be the note well, which is what we need. And then I'll pick up the rest. Shall we give it a few more minutes before we start, Jeff? I'm not seeing Jeff back in.
Sue, can you hear me?
Yes, I can hear you, G. Thank you.
Good. Thank you.
Jeff, I've made it through the slides. This is the note well.
Can you hear me?
Very softly, Jeff.
Okay, let me see if I can adjust my settings.
There it is. I can hear you just fine. Okay, folks, I think we're ready to start. Uh, G, if you're ready with the minutes, I'm watching them, but I'm not sure I'll get to them as I'm running slides. This is a note well. You should note the information. If you've not been to an IDR meeting or another meeting in ITF, you should realize that we all work under the note well. At that point, the agenda is on the web page, and I'm going to go directly to sharing our first presentation by June, which is an update and a discussion. Now, as an interim, we're trying to have a good discussion. There's a great deal of time set out for discussion, so please go ahead and ask the presenter questions, and then if they ask you to pause for a moment, we'll pick up the discussion at that time. Arjun, do you see the presentation in front of you? I'm not hearing Arjun. Anyone?
His microphone session is logged off at the moment.
I can see the slides.
As Arjun was here earlier, but I can see him, but not the microphone. Or
Hello?
there you are, Arjun.
Oh, sorry. Uh, uh, so I will introduce the solution and scenario and the solution for the RDORFO. So next slide, please. The motivation of this presentation, you want to describe the scenario and the solution to control the excessive VPN route within one AS or across different AS. And we want to reach consensus on the proposed solutions and for the updated solution draft. Next slide, please. Yeah, first, we begin the most simple scenario and the solution. We call it intro as different RD and one RT. That is to say, as illustrated within this graph, we have 4 P router within the AS, and the P router and the IR share one BGP session for the VPN prefix from multi VRFs, and the RD is allocated per VPN per PE. So if the in this diagram, if the P3 send the excessive VPN route within this network, the VPN route has the RD 33 and with RT1. This excessive VPN route will be reach the P1 and P2, and will influence the VRF on this device. So we should find some solution to decrease the influence on other VRFs. For example, on P1, only the VPN1 import such VPN route, and it detects the VPN route has exceed its limit. Then it will send one RD ORF message to IR. In P2, there are 2 VPN to import such VPN route. So the P2 will make some judgment that both of these VPN has reached their limit. Only under such condition, the P2 will send the RDOF message to IR. So when IR receives such RDOF message, it will control the VPN route that distributed to P1 and P2. This is the scenario within one AS. So we can next slide, please. In this scenario, it is similar with scenario 1. The difference is the excessive route may attach different RT. For example, the excessive route has the RT1 and RT2 attached, and this VPN route will be imported in VPN1 and VPN2 on P1, and will be imported into VPN1 on P2. The judgment criteria is similar. At P1, only one of the VPN that import such excessive VPN route have reached its limit. Then the P1 will send out the RDOF message. In this example, on P1, only VPN route, VPN1 excessive its limit, so it will not send out the RDOF message. And only the P2 will send such message to IR. So, okay, next slide. This is also in the intro S, but with unique RD. That is to say, for VPN1, the RD1 is allocated on the different P device. The procedure is similar with the previous two scenario, and only the P2 will send the RDOF message to RR. The difference point is that because the RD is same on different Ps, so if the P2 send out the RDOF message to RR, P2 will not receive the VPN route from P3 and also from the P1. This is different from the two scenario as I have mentioned. But we think because the P2 is overflowed, so we think the its communication with P1 will be influenced. We think it is acceptable. Okay, next slide. So this is for the inter-S scenario. The procedure within 1S is same as the previous example. The difference is that the accessible VPN route is from one PE that is located in another S. This accessible VPN route will be distributed via the SBR and then to the PE in another S. So based on the previous procedure, after this, if we take the example for the accessible VPN route is from P3, that is from the VPN1 and VPN2, and based on the previous described the procedure, the PE1 will send the RDOF message with the RD set RD31, and P2 will send two RDOF message. One is the RD set to RD31, and the other is RD set to RD2. When SBR receives such a RDOF message, it will send out only one RDOF message to its upstream SBR, because it receives such a RDOF message from all of its downstream peers. So this is RDOF message transmit procedure between different RAS. Okay, next please. So we give the solution summary. The control message for the specified VPN route can be triggered automatically upon the accessible VPN route, and the control message should be sent out the device. For example, for PE, when all of the VRF on it don't want to process it. For IR, when all of its BGP client don't want to process it. And for SBR, when all its BGP peers within 1S don't want to process it. Or for all of them, the process of such accessible route has exceeded its own capability. I think the logic is similar and unique, so it can easily be deployed within the network for the accessible VPN route. The trigger of the such message is automatic, but the remove of the RDOF message should be manual. to avoid the possible flapping of the excessive VPN route advertisement. And after the discussion within the list and also offline, we have get the conclusion that the RD information is enough for such mechanism. We need not to include the RT information within the control message because the same RT may be imported by several VRFs. And within one P device, RT cannot uniquely identify one VPN, but RD can accomplish this. Okay, next slide. Yeah, this is for the solution for scenario and the solution. We want to now is clear to describe to be described for the problem and the solution. And if so, we want to for the draft. Okay, so.
So are there questions? Previously, when we discussed this, there were a number of questions on different scenarios. Is there anyone who'd like to ask questions on scenario 1? We have plenty of time to go through this.
Hi, Sue. Can you hear me?
There seems to be a lag.
Yeah, there's going to be significant lag. I have network problems, so I think the best thing I can do is make some statements and then go very quiet and try to respond slow rather than fast. So the big problem that we've seen in the discussion about this problem in solution space, I think the problem space is understood pretty well at this point. The desire is that when a PE is overloaded, it wants some way to basically tell the network, stop sending me stuff I will not be able to process. Where we have a breakdown in the problem versus the solution. So here in scenario 1, we have a solution that I think works out okay. It's possible for a PE to tell the router that's sending it that locally it can't handle some set of VPN routes that's coming in. Please stop sending me these for now. I think this piece is easy and understood. Where we start running into problems in each of the layers as we start moving further and further towards trying to propagate this source is 2 issues. Issue number 1 is where there's an attempt to use the ORF in a transitive fashion where each adjacent box sends an ORF to another adjacent box to try to suppress it. And an issue that we have with this is that ORFs are link session state effectively for BGP. They don't have any stickiness aside from that, and that means that trying to trigger these things in a transitive fashion can leave us with problems about how do we choose the graph that we distribute this along. This is a point that I've pressed on a few times, and the scenario 4 that you show as an example has a very simple network without any loops. So just trying to figure out how does the distribution actually happen in a safe fashion is going to be one of the challenges. And this ties into the request in the proposal, do not clear these things without manual clears. How do you start distinguishing a manual clear condition for the originating device for the ORF versus somewhere in the middle? So there's some concern about getting us stuck into a state where we really can't clear an ORF because it's not tied to routing state of some sort. So we have a mismatch between routing can solve this problem by distributing this in some fashion towards the source. And we have, the mismatch in terms of without something like that, we can potentially end up having issues with how does a device in the middle of the network decide that it needs to propagate the ORF filter request further upstream. Upstream only makes sense when you know there's an up and down. I'm going to pause now and let people respond.
Hello, Jeff.
Go ahead, Jun.
Yeah. Uh, uh, as I described, the propagation of the RDRF is determined locally by each device. That is to say, such a message may not reach the source because in this example, if only if PE1 only send out the RD31, but not send out the RD2, then the RD2 message will not be sent out by the SBR1 to SBR1 to SBR2. So the control logic in each device is same. That is to say, such message will not be distributed automatically to the source. It will only be distributed upstream once the condition is met. Do I answer your concern for such mechanism?
So the problem that we have is that if you make this propagation in any fashion automatically, there's no way to tell in a transitive fashion when things clear. So we have a simple topology here where a PE2 feeds to ASBR1 and feeds to ASBR2. If we clear a condition at some point in the network, how do we make sure that we actually clear them out automatically? This is session state, this is not routing state.
Jun, we'll give you time to talk about that, and then we'll pick up Sharari.
As I have explained, the distribution of such message will not be network wide. Such message will only be sent out when the device meet the criteria as mentioned in the draft. So I think this is a controllable mechanism. There will no harm for such message to be sent out. Every device will only send out such device, send out such message when it has determined that it will not handle such excessive VPN route. Siri, please.
On to that, and then Sharari, it'll be your turn. Okay. Jeff, did you have any comments to Jun's comment? Jeff is having audio problems. We'll pick up Shari and go ahead. We'll pick up Jeff later.
Sure. Can you hear me, Sue?
Go ahead.
Okay. I have a clarification question. Even before we look at the solution of RDORF, I want to know how do we determine that this route that we receive from P4, excessive route, is excessive or is not needed, and therefore we should send the RDORF? What if we had heard a prefix, unwanted prefix early on that made us fill up our number to reach the maximum limit? And therefore, is the mechanism being built to detect the right problem? So this is my question.
The question, Arjun.
Yeah. Firstly, we will set the maximum VRF size, maximum root size each VRF. So if one of the VRF have received the excessive VPN root, the number of the root exceed its limit, then it will analyze the excessive VPN root and find out how many RT is associated with it. If only one RT is associated and only one VRF import such VPN root, then the P device can send out the RDOF message out of its device. If there are more than one VRF imported such VPN route, then it must assure that both such VRF have reached this limit. If not, such excessive VPN route will be handled locally. One similar mechanism, but implemented with the device itself. I do not answer the question.
Your voices got little, wasn't clear towards the end, but I think I got the gist. I still have a question. So what problems are we trying to solve? Again, this is more of a clarification question. If I have a policy on the local router, which will look for the maximum number of prefixes, and therefore I won't accept beyond the number if I have exceeded, then the only thing that we're trying to solve is reduce the control plane traffic. And if you're gonna shut the last guy who just sent you the prefix, how do you know the previously accepted prefixes are truly valid than you wanted to have them? I'm still trying to see whether this is the right solution and the problem for that as well. So if it is not clear, I can send an email as well.
Okay.
Arjun, is how are you detecting it? Is it policy? Is it a limit exceeded? What causes the detection that this particular route is the guilty party for exceeding your limits?
Currently, our our consideration is that if we set the maximum limit on HVRF, and the device can implement such mechanism, then the control message will be triggered automatically. No, it does not need additional policy to utilize such mechanism. Or from another point, if we do not have such mechanism, then the overflow of the one VPN will influence the process of the the normal route on other VPNs. So we need some finer control for the excessive VPN route. This is the main consideration for our scenario and the current solution.
I'm lost. Perhaps you could also chat. The voice quality is causing problems. Hi, can everyone hear me? Care, can you hear me?
I can hear you.
Okay, Arjun, the speaking quality of your sound is causing us problems. I can't hear exactly what the solution is. Maybe you'd type that into the chat discussion while Care brings up his point. Would that be okay?
Can send the question on the list, and we will respond quickly for the comment. Okay.
Sue, I can go next. Sue, can you hear me?
Sue seems to be running slow as well, so I'm going to try to police the microphone. Kayer, you have the microphone.
Thank you, Jeff. Speaking as a working group member, I have the same question that along the lines that Sri Hari had. If you have same RD for all VPNs, meaning for a given VPN which is spread across different sites, I'm wondering how an RD-based mechanism will work. On the other hand, if you really want a granularity across sites within a VPN, why wouldn't a different why wouldn't a different RT approach work? And that was my question.
Sure. Would you like to send your question on the list? I will respond. Okay.
Anchor, you have the microphone.
Oh, hi, Jeff.
We can hear you.
Okay. I have two comments. The first comment is it's basically I would like to echo what Srihari and Kyo just said. Basically, I feel that it is okay if you want to define a VPN based on the RT in one network, one domain, but it's very difficult to do to do the coordination when once basically such a definition spans over multiple networks, that is multiple ASs. So that sometimes this the effort for coordination may not be practical. Second question is this. I think in general, I think as we have learned and also established the concept has been established for many years. In general, we can apply any policy across the eBGP boundary, but it is in general not safe to apply policy, the filters across RBGP, because in general, RBGP needs to be consistent, right? Here, so that's a general question. That's why it's a general comment. That's why it's always very difficult if you say, due to memory or resource constraints, you want to filter some routes, accept some, but reject others on RBGP boundary. That has been very difficult to do, regardless whether you use you use OIF or you use any other type of filtering. It's really it's a very challenging problem. So far, I have not really seen a good solution. Say, filtering or a MAC list and say, okay, it's safe to filter on RBGP boundaries. Because in this particular case, when I look at the diagram, you say the PE1 is actually interested in the routes, that belong to particular VPN. It's different from the case, say, okay, this PE1 has no overlapping route target. It's not interested. That's why they don't want it. If they don't want it in the first place, then it's okay to basically filter them out. But in this case, if this PE1 is interested in this such route, and in general, I don't think it's safe to filter in case of resource issues. Yeah, that concludes my comments. Thank you.
Here, I want to make a brief response. Such VRF VPN route are interested by this PE. So we cannot use the RTC mechanism, because RTC mechanism will filter the uninterested VPN route based on the overall plan. So the RDORF message is to filter the excessive but interested VPN route. Yeah, but if we do not control such excessive interested VPN route, then the process of such route will influence the performance on RVIF on the SMP device or SMSDR device. And the excessive VPN route, the RD of the excessive VPN route can't be determined in advance. So we also cannot configure such RD on each device. So we think such mechanism should be triggered automatically under some deterministic condition or environment. I think the behavior of the PE and the SBR is also determined because they based on the same procedure or same mechanism. Okay.
So that's, I think, what we've been trying to ask is, what are the deterministic conditions that you're placing? Are they based on policy? Are they based on something? How do you uniquely know that this interdomain case has been triggered? What set of policy? Giving us an example will help us work through this. I think that summarizes it because as Anchor and as CARE and Jeff has indicated, the interdomain case, the policy is not easy. What example can you give us for that?
We can discuss based on this scenario. One, that is to say, one SBR receives the RF message from all of its IBGP peer. For example, it receives such message from T1 and T2 for the RD of message with RD set to RD31. Then SBR1 know that all of its downstream peer don't want such excessive VPN route. So it will send out safely the RD of message to SBR2 with the RD set to RD31. But for example, for the RD2, only P2 send out such message, and another peer, IBGP peer, for example, P1, does not send out such message. So SBR1 will filter the VPN route that with RD set to RD2 locally, and it will not send out RD of message with RD set to RD set to RD2. Is it clear to describe the mechanism? So I know we have some summary for the solution in next slide. Would you like to? Yeah.
So I've put it forward to that slide. Anchor, do you does this answer your policy, the questions on what triggers it? I'll make sure we've answered yours before I go back to mine.
So my question or my comment is really it's more general. It's a general question. It's not about specific this OIF-based mechanism. It's in this case. I mean, you guys must have remembered discussion about the max prefix feature, right? Across the eBGP boundary. Although it's safe to apply policy, say to drop the update for any prefixes or any one of them. But in practice, actually, it's very difficult to design because then it's the issue is this: which one? In some cases, not all the routes are equal. In some cases, it's the one route is more important than the others. Now, then it comes to the discussion of, okay, really, when you exceed the maximum prefix, which one do you drop? Obviously, you want to drop the one that is less important to you, right? But that varies from one customer to another, right? So that's although in general it's safe from protocol's point of view, from the correctness point of view, correctness of the protocol operation. it's it's safe to do across the eBGP boundary to do the max prefix. And but it's not easy. It's not easy. There's no easy solution to say which one to drop. On top of that, I think that question or that issue exists in this particular case as well. In addition, here we are talking about applying policies to IBGP to filter out some routes that this local router is actually interested in. So that's another, I think, a bigger question for me. It's not clear how you can do it safely. In general, it's not about to say, okay, OIF, this is how I will trigger it. It's really, I think, the first, perhaps the first, as Shu was alluded to, it's really the definition. Say, okay, the mapping comes next as the second step, but the first step is the definition. How do you decide which RD or which VIF routes to drop, right? That's not easy. It's just like the case when we are short on memory on a router. What do you do? Which processes do you start to to kill? There's no easy solution. And in the end, I think for the vast majority cases, the best solution is to add more physical memory.
Sorry, but we've gone about 45 minutes on this first topic, and I appreciate Anker's point. Arjun, I think you have to really understand that the questions that Shihari and Jeff and Anker are asking are about the automatic engagement of this procedure in the interdomain case. I think you need to consider that and provide some detail. Jeff mentioned he would send some of his comments via the list, and maybe Anker and CARE can send some additional comments. But I think we probably should go on in all fairness to our next presentations. Arjun, thank you for the lengthy discussion.
Can you hear me?
Yes, I can. Please go ahead.
Okay. I'm Tony from China Telecom. Let me introduce the content of BGPRS with multi-topology for SR-based VTN. Next slide, please.
Just a minute. Do you see it now?
Yes.
Okay, thank you.
There are some basic terms and mechanisms should be declared at first. The draft IETF's enhanced VPN specifies the framework of enhanced VPN and describes the candidate components technologies in different network spans and layers. The definition of VTN is introduced in this draft. A VTN is a virtual underlay network that connects customer edge point with capability of providing isolation and performance characteristics required by an enhanced VPN customer. The next draft, Ietf Spring resource-aware segments introduce resource awareness to segment routing and defines the resource-aware segments. The mechanism and procedure of building SR-based VPNs are described in draft Ietf Spring SR for enhanced VPN. Besides, the IGP mechanisms for SR-based VPN are discussed in LSR working group. The draft IETF LSR is SR VTN MT describes an IGP mechanism to advertise the association between the topology, resource attribute, and the SRCs for each VTN. Similarly, this document describes a mechanism to distribute the information of SR-based VTNs to the network controller using BGPLS with MT. This mechanism describes how to distribute the within the topology and resource attribute to the network controller. In addition, the inter-domain topology and T attributes of VTNs are also considered. Next slide, please. This slide shows a virtual transport network is a virtual neural network which consists of a subset of network topology and network resources located from the physical network. So in order to allow the network controller and network nodes to perform the shortest path computation, the centralized network controller needs to distribute the resource-aware seeds and the resource attribute in the control plane. So BGPLS is used to distribute the inter-domain topology and the associated T attribute of the VTNs to the network controller. Next slide. Several mechanisms are introduced in this document. The first one is MTID. It is reused as the control plane identifier of VTN. It is assumed that each VTN is associated with a unique logical topology. The second mechanism is intra-domain topology. MTID TLV is carried in BGPLS link NLRI prefix NLRI to advertise the per VTN topology information. Topology specific SRCs are advertised using BGPLS SR or SRv6 extensions. The third one is the inter-domain topology advertised mechanism. MTID TLV with BGPLS EPE is used to advertise the per VTN inter-domain connectivity and the topology specific peer adjacent seed, peer node seed, and peer side seed. MTID needs to be unified plan to ensure the consistency both in each domain and on the inter-domain links. Next slide. In addition, this section describes the mechanisms to advertise the resource information associated with each VTN by using BGPLS mechanisms. As we know, one link can participate in multi-VTNs. The topology-specific T attributes are used to specify the resource allocated to each VTN. Use MTID TLV in the link NLRI, then the maximum link bandwidth sub-TLV is used to advertise the subset of bandwidth allocated to the VTN identified by the MTID. Furthermore, the advertisement of other T-link attribute per VTN is for the further study. Next slide. Certainly, some scalability considerations are included in this document. Each VTN is associated with a unique logical topology. Independent topology or root computation for each VTN is needed. When a link or prefix participates in multi-topologies, separate NLIs need to be generated to advertise the link or prefix in each topology, together with the topology-specific seeds and T attribute. Therefore, this may increase the number of BGP updates advertised to the controller. As a result, the MT-based SR-VTN mechanism is applicable to the network scenarios where a limited number of VTNs is needed. Next slide. And this is the third version of this draft. In this version, the document type has changed to the informational, which is the same as the IGP MT-based SR VTN draft. In the scalability consideration chapter, we add some text to clarify the applicable of the MT-based SR-VTN approach. Besides, a reference document list has been updated and editorial changes has been done as well. Next slide. We think the content of this document is stable, so is it possible to consider the adoption of this document? That's all. Thank you.
Thank you. Kung, just a minute while I ask for question. Are there questions on this informational draft, and how it the MTID is being used? Go ahead, Jeff.
Hi, hopefully this is more stable. My question is a simple one. Why IDR for this one?
In contrast, I suspect Jeff is asking why not best, which does a lot of application drafts.
Or even T's?
Originally, pardon, or T's. When it specifies changes to IDR, then that's an important piece to put in. Excuse me, when it specifies changes to BGP, IDR is important. This seems to be informational. Can you help us determine whether this should be IDR best or T's?
Please take to the list. Maybe the 冲锋奥杰 can answer this question.
Okay, we will take it to the list. I will type the question in the chat room so that you can see it early. Okay, let's pick up on the next presentation. I'll give the Kanjafume. I will let Kanj take a few moments, and please tell me if I pronounced your name correctly. I apologize for that.
This is Chongfeng. Can you hear me?
Yes, I can hear you.
Yes, this is this draft is about carrying VTND BGP protocols for the communication between controller and network element. So so I think it is suitable to be put in the IDR working group. It is also a counterpart to the another draft in LSR working group. So I think this.
But you're not defining the MTID in this draft. You're only defining its use. Am I understanding this draft correctly?
Yeah, this is only informational. It's about how to use MTID in BGP.
Okay. The question then has to do you feel it's more appropriate in why not best? Is a question that our AD will probably ask us as well. So if you could consider that, it would be helpful.
Okay, thank you.
If you would send a note to the chairs, or actually more importantly, send a note to the list so we can understand why before we do a working group adoption. Okay?
Okay. Okay, thank you.
And if you think an answer is, you can provide a quick answer while we set up for the next presentation, please go ahead. Anchor, you will be next in just a moment. Okay. Any final words before I switch to Anchor's presentation, Changfen? Okay, if you want to come back later in the discussion, please let me know. Anchor, would you go ahead with your presentation, and Changfen and Hong will come back at another time. Please answer that question on the list. Why not best or tease? I realize it's informational and specifying something for BGP. We'd like a clear answer to be able to give it to our AD. Okay. Anchor, please go ahead.
Hi, Sue. Hi, Sue. Can you hear me?
Yes, I can. Please go ahead.
Okay. Yeah. So since hi everybody. Since the last Ietf in July, so we have made some mostly editorial changes to the draft. So the 03 version was posted, and but this presentation is not only about the delta between 02 and 03. Actually, last time, because we didn't have we ran out of time, there was no time for folks to ask questions. So I did receive a couple questions. I think one was from Sue. So for some clarification. So basically, we incorporate them into this presentation. Next slide, please. So what is the motivation of the draft? Well, it's actually because I have to apologize to the working group. It's basically, I think I dropped the ball. This was the issue was actually was discovered a long time ago, and we sort of proposed a solution. It turned out to be partial, but for one reason or another, we didn't basically follow up for a long time. And recently, this from time to time, the issue would show up in the field and would see by the customers. And recently, there's another incident. Say, okay, this is not working. This is a backup static route. So what happened? Then I realized, okay, I did a very poor job. Didn't finish the work. And the issue actually has not been addressed. So the motivation here is really to basically explain and also document the non-deterministic behavior that exists. And this is really is not a well-known issue. And when people basically run into it, it's very frustrating because the behavior is non-deterministic, right? And so we also basically we would like to propose a solution to address the issue. And there's a config option. There's a basically software implementation option. So we would really like to promote implementation the software to address the issue as a default behavior. So these are the motivations. Next slide, please. So these are the problem statement, right? It's if you look at currently, we have I think conceptually and also I think a lot of implementation follow this the idea as well. Basically, you have a rep writing information table. That's where it aggregates the rods from different protocols. Then we have BDP. They interact with each other, but currently, as far as the BDP is concerned, BDP spec is concerned, we do not actually. There's no provision for the correlation of the rod selection accuracy between RIP and BDP. RIP, as everybody know, is basically use the admin distance as a tiebreaker when you receive rods from different protocols. And I think in some cases, the KD and Juniper uses a protocol preference. They are basically, I think they are pretty much equivalent. But admin distance, I think, is more commonly used as a terminology. And if you look at BDP, we have our own path selection algorithms basically starts with a local pref comparison, then you have AS path length comparison, etc. Right? So these two, there's no correlation. So here the issue is that when you redistribute the backup rod is determined by admin distance. Say one is more preferred than the other become a backup, right? And so when you redistribute backup rod that's into BDP, then the long-deterministic behavior would show up. Depends on the order of the arrival of the path. Usually the path that arrives first would win and will stay as the best. Versus that certainly it's inconsistent with the design with the routing design to treat it as a backup, right? And so this in the draft, I think this as basically the examples. These are really simple examples. You have the behavior would show up on not only a single router, as it also shows up when you on single router. Basically, you have the case of certainly you have eBDP rods, a eBDP rod or a static, for example. These two would compete with each other. One is the primary, the other backup, and depending on the ordering, you have non-deterministic behavior. And then on multiple routers, certainly on multiple routers happens more. It's more common. Basically, you have the primary path on one router, and the backup is on another router. That's a typical case. It's the primary backup. Again, depending on the ordering of the path arrival, and either one router or multiple routers in the network would add up with different route elections. So that's also non-deterministic. And when you have a rod reflector, I mean that's a detail in the draft. These are really simple examples. It seems that folks do not have a question on these examples. So in this, in particular, I think in the second case, network-wide behavior, when you have a rod reflector or confederation involved, the problem now can become more obvious, right? So these are day one issues. It's because we have I think in this case I would classify it as when we design protocols, there's a over specification, add specification, and the right specification. In this case, I think it falls into the category of under specification. The behavior is not defined clearly, and so it's the spec is one thing, implementation is another, right? The implementation, the issue exists in basically a number of implementation. And I think as Jeff pointed out, it's actually it does not the issue does not exist in all the implementations. I think Jeff pointed out the GD and the Junos or the GD derivatives, they actually have taken care of this. I think the single router issue, because that's where basically the admin distance or the protocol preference is actually considered as very early before you do the all the other comparisons in BGP, such as local pref. So that's really good news. That's consistent with I think with what we're trying to accomplish. But I think in general, so there's a spec is under specified. It's not there, and also the I think the network-wide cases are not. There's no good solution. I don't think there is, because that's certainly not enough to just look at admin distance or the protocol preference. And so if one is aware of this issue in deployment, right, and also the solution, you could do configuration, sure, but because the issue is not well understood and it's not well documented, it's for a customer that sort of is not aware of the issue, it can be very frustrating in the network operation when you run into this issue. Next slide, please. So the solution, right? I think so basically it consists of I think the two portions of solution. One is on a single router. So basically the idea is to make it consistent among all the paths with no admin distance. So which are these? Which are these routes or these paths? Basically, it's for locally redistributed one, we certainly know, and also for eBGP learned, and also locally aggregate, because basically when we download them into the RIP, populate from BGP into RIP, we know, and or if it comes if for redistributed routes, it comes from RIP, we also know. So this basically we deterministically know. So in that case, it's just a comparison. The admin distance pick the basically most preferred one in BGP route selection. This would be the before the local pref comparison, right? That way you make sure BGP and RIP are consistent in terms of the locally originated, locally sourced routes, right? This is basically this has been taken care of by I guess from the AD and Junos derivatives. That's good. There's no conflict. I don't see any conflict there. So it's the approach is the same. So what that should take care of the single router. What about this sort of primary backup on two different routers, right? So this is basically involve IBGP routes. You really do not know when you receive an IBGP router, you really do not know what is the real admin distance of that guy because it's already lost, right? So what we have is really the local pref. You basically the suggestion here or the recommendation here is basically to use the local pref for network-wide influence because this is already available in BGP. And it's basically it's propagated, right? So it's basically if you know this is a backup route, this local route is supposed to be a backup to another route, another path from IBGP, then the local pref value should be lowered for redistributed backup routes, right? So that's the idea. Here, if you say you have a primary and backup. The two paths in the network. That's pretty easy. You lower it, that should take care of it. But the question is that generic enough? What about if you have if you have three paths in the network? You have the primary, secondary, and tertiary. What is the simple solution? So the solution is still here. Basically, we propose in the draft is basically you rank them. You say, okay, this is my primary, secondary, tertiary, and then you have apply offset to the admin distance. right? Because the admin distance, I think several people point out, it can vary. The default admin distance can vary multi-vendor environment, and that's okay. So what here suggest the idea is basically you write the primary, second, tertiary, the offset you assign a sort of log. Conceptually, you assign offset. Secondary, you say offset is 10, tertiary is 20, for example. And then you basically say you assign the admin distance, use whatever admin distance on that router locally, then plus offset. That would be admin distance for that backup route. And then you can basically calculate your local pref. It's a default. You have a default local pref. That is common in the network. Then it's a local pref for this backup route, redistribute backup route would be the default minus the offset, right? That way you order, you basically now the local, this local pref will reflect your intention for this, secondary, tertiary, the path. The configuration option, right? Certainly it is there. I think some people are using it today. It can be used to override the automatic setting. Next slide, please. Yeah, so I want to spend a little bit of time on this. So this software option versus configuration option. It's all about I think if it's not clear, I want to emphasize, it's really about the default behavior. So that's why we basically say we recommend the implementation of the simple algorithm. You basically make the default behavior deterministic. I just make it work. That way, we can actually, in most cases, we will be able to avoid the configuration. That would simplify the network operation for our operators, right? And here, actually, I want to rephrase the second point, the slide differently. User config, you can always use a config, right? User config if before this the algorithm is implemented in your software, right? To achieve the desired behavior. And so basically, the was manually set the weight if applicable. For some implementation, that is the step even before the local pref. The RAS selection for some implementations, actually for a lot of implementations, and also the local pref. That way, it's if you have a more sophisticated policy, you can always use the config to override the automatic setting. So they can coexist here. Basically, they are. I want to go a little bit further because I think we have a little bit time. So basically, if you have an existing deployment, if you already have a config, there's no conflict because here, even if let's say software, right now, software implements this algorithm and then whatever setting we do, and then it's as we all know that then the configuration always overrides default behavior. So if you, for existing deployment, if you use today, if you use a configuration to do the setting, there's no problem. There's no conflict because the config will still take over, right? If today you without config and you are not aware of this issue, sometimes it works, sometimes it does not. It's non-deterministic. Now, with whether it's the algorithm implement software, it will just work. It will become deterministic. And the fact you don't have a config, that it does not really matter in this case, right? And for future deployment, let's say for new deployment, right? Once your router software has the implementation, then you basically now become simpler. You don't need to set the way to set the local pref for the backup route that is being redistributed. It will just work, right? So if you want to, if you feel more comfortable using config, that's fine. And I say there's no conflict. Config always, overrides the default behavior in the software. So the flow, right? The flow of this library distribution, right? When you apply policies, basically, for example, local pref setting or weight or this. It's basically software has a setting, default setting in the implementation. And then the second step, right? The flow is second step is you apply the configuration. So if you have any configuration or you want to use any configuration, there's no problem. There's no conflict, right? I think that's one of the questions I think Sue was asking me before. So there's no conflict. That's what you can continue to use config if that's you prefer. But for people basically who are not aware of this issue or who want to basically want to reduce configuration, so the algorithm will allow you to basically to minimize that work, right, and make it deterministic. So that's what I like to point out. Is the software configuration, what's its configuration option, and the basically there's no conflict. They work together nicely. I think that's the last slide I have.
Any comments, folks, on this topic? I know I've seen Jeff have a few discussions with Enke on this. Anyone else on this topic? I don't see anyone in the queue at this point. Go ahead, Jeff. You can just start right in.
Hopefully you can hear me now.
Yeah.
So I'll keep this short since some of these are restatements from the list. I had mentioned that you can address some of the determinism issues in your own implementation without necessarily having to push it to BGP. And my suggestion to you is that's probably worth considering just because it makes a lot of your life for your customers a lot easier. But more importantly, I think the thing that you're sort of getting to more broadly in the draft, although it's sort of covered as a secondary point, is you're trying to get the network level determinism of those local admin distanced entities and how they get chosen across the entire network. The thing I think you're going to run into as an interesting problem is that these knobs that we have for admin distance across all the implementations have values that have been in there for a lot of years, and people tweak them sometimes a little bit. Sometimes they go through radical changes, and the critical thing is people have made choices that have consequences already in their network. If your proposal is specifically to try to get some level of uniformity to do some of these auto calculations and push it off into your local pref, basically by math, this value minus this value equals this, stick this value into local pref. I think what you're going to find out is a lot of the current operators are not happy with the results they can get from what seems like the obvious solution. And I think that's going to push you very rapidly towards a simple mapping operation. You did mention that, where instead of doing math on things, you have mappability of on this router, this distance means that it maps to one of the following values for local pref. If you talk about that in your proposal, I think you're going to find it a little bit more broadly accepted and probably matching what people tend to do in their networks already.
So Jeff, I think, yeah, you certainly raised several good points. Let me try to address them. The first one is basically say, okay, if this is something that some implementation are already doing, I guess from my reading of the questions, is this something still we want to pursue? I think I answered the question on this first slide, the motivation part. Sue, if you could you go back to that first slide?
Do I have the right one?
Yeah, this is the one. Yes.
Okay.
So here, if you look at it, right? So these are the goals, right? it's really the behavior is not. It's as I understand, it's partially addressed by some implementations, but it's not well documented, and it's not also it's not well known. It's not well known. And second thing is this. Next slide is true. It's if you look at basically because here to address it, right? Like what KD and Junos is done for the single router case. Actually, that is a change in the BDP best path route selection algorithm. It's really if you look at BDP spec, it does not cover that. So if it's useful, right? If this that enhancement is useful, as has been shown in the field, let's document that. Let's put it in the BDP route selection. Right here, that's what I say is add a specification in BDP, right? And also it's because this touches on the BDP path selection. So I think one of the Jeff's question was why not drone? My understanding is that the moment it touches BDP path selection, if you want to do enhancement, it has to be in RDR. So it's also I used to think, I think previously also, I think we want to make it informational, but it was people point out, say that no, that's a no. You cannot make it informational if you want to enhance the BDP path selection, right? The second thing that there are really two parts to the solution. One is you say making it deterministic on a single router, just using admin distance for locally sourced routes, right? Like what has been done in KD or in Junos. You basically say, okay, I'm going to look at my admin distance or protocol preference before compare local preference. That's exactly what it is. I think my understanding is that they are equivalent, right? That's the first part. Second part is the network-wide. Network-wide, as I said today, if you already apply policies, there's no problem, okay? You will continue to apply policy, but we will just make the default. I think goal is basically make a default work, make default behavior deterministic. And if you apply policy, your policy will always take over. So I think I would like to understand a little bit better from different implementations to see the simple mapping, why the simple mapping would cause a problem. Right, it's basically say, okay, based on my admin distance, when I redistribute, I know it's a backup to RBDP. Then when I basically convert that into the local pref value, is there really a problem? So far, it's I think I have not really received. I have not heard examples say this will not work. But I think we have, of course, we have not. There has not been enough time for the discussion and for the feedback. I think that's the area I would like to understand better. But I think the key point is this: there's no conflict with configuration, right? If you're already doing something using configuration, that's fine. That will continue to be the case. That config will overwrite, right? So here, what we are proposing is really about the default behavior. Make the default behavior work. That so people do not need to deal with this kind of non-deterministic behavior. It's not always easy. You see, it's as I think a lot of us experience, either something work or does not work. It's the work is good. If it consistently not working, that's also easier to deal with, easier to fix. If something is in between, it works sometimes, it works not in other times, that's much more difficult. And that's what we are facing. I think, Jeff, certainly we can I think you have another points, and I think we can certainly, I like to let's have a more depth discussion. I think I will give you a call. Let's go through them and we can summarize to the list.
Right. I'll finish my summary comments on. I think local pref is a perfectly fine way to do this sort of thing to do network-wide type stuff, this is exactly what people tend to use it for. What you do on your router to set your local pref is up to you. I think the interesting open question is going to be, we had intentionally left a lot of discussion about how redistribution worked when we were doing the 4271 work, because nobody
Certainly.
wanted to touch that. It was an atomic bomb, and people are unhappy with having that discussion. So I think that will be an interesting bit of process discussion. I'm done.
Yeah,
Thank you.
certainly, Jeff. Yeah.
Okay, what I understand from Jeff and Anchor is they're going to take up this interesting application to the list. Is there any other questions that you want to ask of Anchor before the Jeff and Anchor continued the discussion on the list? I'll give a few minutes for people in case you'd like to chat. Okay, we're going to take a little bit of a re-spin on our discussion. I felt it was extremely important today to go through a longer discussion on the RDORF solution. Arjun, with BGP PC solution, I've given you enough information to help Dhruv. This PCE solution is really matches our some of our auto configurations. I'm going to have to move this to the end of the presentation list. If it falls off the end, it will go on the interim on BGP auto configuration because it does do BGP auto configuration. So I recommend people to read the drafts, but we may need to pick that up in a different interim. We're going to switch over to Jeffrey Zhang. Jeffrey, if you would prepare to get ready for your presentation, I will bring your presentation up next.
Yes,
give
please.
me a moment.
Yeah, I'm here.
Make sure I've got the right presentation. There. Do I have the right presentation at this time?
Yes.
Would you please go ahead then?
Okay. So this has already been presented last time, but the idea is here we can to get more discussion and then see if this is a useful thing. Next slide, please. So we are talking about deriving extended communities from route targets. The general example use case is described here. If you consider that you have a VPN that has, say, 10 Ps or 20, does not matter. And for that VPN, we use a route target, let's call it RT1. The route target is an extended community, and then we call it EC1 that has a subtype 0x2. In this case, RT1 and EC1 are exactly the same. But when we say route target, we emphasize that it is a special extended community that is used to control the propagation and importation of routes. But when we don't say route target, then it does not have, we don't emphasize on the semantics. Now, consider that one particular or some of the PEs need to propagate the route to just one PE or some PE, but not all the PEs in that VPN. Yet we still want the receiving router or receiving PE to be able to associate that received route with that VPN. So to do that, we need to attach a new route target, let's call it RT2, to that route, so that only the intended target PE will import that route. And now to associate that route with that VPN, we need to attach another intended community. Now, in this case, RT2 and EC2 are not the same. And it's not the same as RT1 either. The reason is that if we use RT1 and to indicate that it's associated with the VPN, then all the PEs will import their route, which is not our intention. So additionally, the EC2 that is used to indicate that it's associated with the VPN, it can be an arbitrary extended community configured on the sending and receiving PEs. As long as both know that it's related to that VPN, it will work. But it would be nice to be able to derive that EC2 just from the RT1. So you have the RT1 from for that VPN as a route target, then you can derive EC2 from the RT1, but it does not have the semantics of a route target. Next slide, please. So for that purpose, we define this way to derive it. Basically, for any RT, you just change the subtype to a new value, and for that derived extended community, you can attach it to the route. And because it does not have the route target subtype, then it's not going to be used to control the propagation and the importation of the routes. And so it can be used to associate the route with the intended VPN. So this is just an informational draft. We have requested a new subtype 0x15 for this purpose. So just want to share this idea with everyone here, so that if you have a similar use case, this is available for use. Next slide, please. Here I listed some specific use cases that basically follow that falls into that general use case bucket. I don't think I need to go through the specific use case, so we can discuss on that general use case. I think that's about it. I hope that made myself understood, and I want to hear your comments and to see if this is a useful thing that can be applied for other use cases. And if this makes sense, it's a simple draft. I'd like to seek adoption.
Jeff has something in the chat room. Jeff, did you want to bring that out to the rest, or did I misunderstand which draft that was relating to?
I see both drafts are in the agenda, so when this one's brought up, I started talking about this one. There's another one on a different topic. Okay. It's also a very short draft.
Yeah. Jeff, did you want to go ahead?
Yeah, very, very quickly. So there was a draft for legacy RTC, which was adopted by IDR, but I don't know if this made much in the way of progress. I believe Cisco may have an implementation. The relevant observation from there is that's another example of taking one extended community, changing it into another, so some other component of the network can deal with it in a slightly different fashion. So the idea is not new. I think Jeffrey's example of something that's just a little bit more generic than the specific RTC case.
Thank you. Good to know.
And I'll make a quick comment to that with regards to legacy RTC. Jeffrey, maybe what we can do is we can combine, if there is a potential to combine both, and then just get it going along.
Sure.
This is speaking as a working group member.
Okay, thank you, Pierre. Well, I'll follow up with you.
Super, thanks.
Yeah.
Jeffrey, any other comments for Jeffrey on this draft? This is the time to provide him feedback since his slot at IDR got very short. I see one from Zahu Zhang. Go ahead, Zahu.
Oh, I'm sorry, that's me.
Oh, that's you. I'm sorry, Jeffrey. My apologies to missing that. I will then just go ahead and provide you with the next presentation. My apologies.
Oh, no problem.
Okay, you tell me if I get the right draft. Do I have the right draft
Yes.
for you in the next presentation? Thank you very much, Jeffrey.
Thank you. We can go to the next slide. So in the newly published 9012 for tunnel encapsulation attribute, there is a MPLS label stack sub-TLV defined, and there is a text saying that if there is a label stack sub-TLV in the tunnel, and when a packet is to be sent through the tunnel, then that label stack must be pushed before any other labels. So when I read that, I had a question: why before? If you want to steer the packet using the label stack to the tunnel destination endpoint, shouldn't you push that label stack after you push the service label? So the RC is not clear about it. Does not talk about why it was pushed before. So I asked around and found out that the intention of the label stack sub-TLV is not for steering traffic to the tunnel endpoint. Can you go to the next slide? Rather, it is to steer the traffic after it had reached the tunnel endpoint. In this example, we have the core, and then we have site 1 and site 2. The border router 1 got that tunnel encapsulation attribute attached to a route, and send the traffic to border router 2. And after border router 2, well, when the BR1 sends the packet, it actually impose a label stack that is going to be used by BR2 to steer traffic through site 2. So that's the intended use case. Now, that is clear now, but what if you have a use case that the controller tells BR1 how it should steer the traffic through the core to BR2 using label stack? Right now, the RC does not have that mechanism. Next slide, please. So if we want to do that, we can define a new sub-TLV. This time we don't call it MPLS label stack, but we just call it tunnel label stack, or any other or better name. That sub-TLV is to encode the label stack that is used to steer traffic to the tunnel endpoint, not after it reached the tunnel endpoint. The encoding wise is the same as other existing sub-TLV besides the type. Next slide, please. So this is a simple small draft that clarifies a use case for the existing sub-TLV and define a new tunnel label stack label stack sub-TLV for traffic steering to the tunnel endpoint. So simple enough. I hope that makes sense. And if it does make sense, then we would like to get adopted.
Comments, questions G's first on the queue, I think, and then Care. Go ahead, G.
First of all, thanks for the clarification about the existing sub-TRV. I didn't realize it was for the steering after the endpoint. Well, for the new TRV, can the existing like SR policy provide a similar functionality as to steer traffic to a specific endpoint? And what is the specific use case for this new TRV?
Yes, you can use SR policy, use a different subsidiary for that purpose. But if you have a network that does not use SR, and so notice that this is purely MPLS without mentioning the SR at all. So it's just another way to do things without requiring segment routing.
So it's not segment routing capable network?
It does not have to be.
But still use a label stack to steer the path.
It could be. For example, if you have multiple RCVP tunnels or things like that, you can specify which one to use.
Tunnel stitching?
Not exact tunnel stitching. Basically, just specify which tunnel to be used for BR1 to reach BR2. A label stack could be could be just one label as well.
Oh, if it is a one label, I'm not sure whether the existing tunnel attributes can cover it.
I don't see it's covered by existing ones.
Okay, I will double check the tunnel types in the existing RFC. Okay, thank you.
Thanks.
Care, please go ahead.
Yes, Jeffrey, you're right about your understanding on the tunnel and cap with regards to multiple labels pop. Independently, I think we are also working now, speaking as a working group member, on a use case that does exactly the same without the use of controller. So I will connect with you offline and see if we can come up with a unified solution on that.
Super. Now we have there's two drafts we can collaborate on.
Yes, count plus plus. Thank you.
Yeah, thanks.
Other comments for Jeffrey? And I do not see anything else. Robert says could be inferior metrics that best path selection uses. That's just from the chat. Again, I may have that on the wrong place. Okay, Jeffrey, if there's nothing further or no one else, we'll go on, and we're going to pick up at this point. We're going to pick up Guyan. You're going to have a few minutes since you got short cut last time, so please be ready.
Okay, thank you.
Please go ahead. Station. Guyan? I'm not seeing Guyan in the list. Is everyone perhaps he had to go, or perhaps we're having connectivity issues?
I do not see him either.
Okay. Well, then we're going to go briefly, Arjun, to the PC solution because Dhruv has wanted some feedback. Let me pick that up and give a short intro so we can go quickly through that. And maybe we'll get through the rest of them. Just give me a second. Okay. If Guyan comes up, we'll work on this. So, Dhruv, can you give us a little bit of an intro where this is in the PCE process? I'll see if give Dhruv a moment. Just break in and interrupt me, Dhruv. My understanding is that this is at the end of its process and we're looking for a review. What this is it's really one of the auto configurations. Let me get to the right place where the PCE controller is actually configuring this particular set of routes, maybe as an RR that's configuring R1 and R3. So the path can go first. So it's really one of our auto configurations. Arjun, in interest of time, could you go through these two scenarios and we'll hope Dhruv can give us a moment of where it is in PCE's syndrome. Dhruv, are you there? Can you at least chat where we are? Okay. So go ahead and explain what the PCE controller does, and we'll try to do a short form of this.
Yeah, hello.
Hi.
Yeah,
Go ahead.
so I can explain simply for the scenario. First we can see the dual multi BGP solution. You know, if we want to different the traffic from different pair IP prefix pair, then we will build two BGP session between R1 and R3, and the different BGP session will distribute different prefix. So using the different loopback address. So, for example, on R1, it will have the different next hop for the different prefix, and the last step is we change the hop, change the path to the BGP next hop. Then the final forwarding path will be changed by the recursive process of the BGP and the IGP. So this is
So if
the
you
key solution for the multi BGP system. It is the
so
same for the scenario in the large network. When the IR is involved in the right diagram, the difference between these two diagram is the in the right diagram, the BGP system, IBGP system will be built between the R1 and the RR, and between RR and R7. The prefix distribution process and the BGP next hop, the path to the BGP next hop manipulation process are the same.
And thank you. One of the as you mentioned, the key part is here that this is an example of a BGP auto configuration where the PCE controller is being used to configure peering sessions between two BGP peers, R1, R5, or and that the RR PCE controller is also being able to configure R7. So it's a BGP auto configuration. The PCE folks have particular language which using PCE sets up the same information we've defined in the BGP auto configuration. So part of the feedback that we have is both the mechanisms and descriptions, but also it's configuring IP address and AS information. And that seems to be all. So I think it fits within our BGP auto configuration work. The interesting part that we want to consider as a working group is what happens if PCE is interacting on a BGP auto configuration. So I wanted to bring up this draft briefly, and we'll bring this again up at the BGP auto configuration interim. If it is in the final stages of PCE's working group calls, so if you want to send some information in early, that would be helpful to both the June and to the PCE working group. And due to time, June, if you let me go ahead and just stop there and point people, I'll go up and pick up the last presentation. Would that be okay, June? Again, I encourage people to pick this up out of the PCE working group. And thank you, June, for letting us catch up on our schedule. Okay, our last presentation is one where I'm going to take off my working group hat and provide you with some details on one of the drafts under working group adoption. Linda is the main author. Robert and Kosik are here as well with myself. So first, let me tell you how we got into this. One of the things in the tunnels we had initially was tunnels with IPsec. And IPsec has been a tunnel discussion for a long time. The earliest VPN drafts had tunnels. This particular hybrid use case has been discussed in BEST and RTWG, SD-WAN, and I'm sure you've heard Linda go through it. So I'm not going to go through the use case as it seems to be accepted by BEST and RTWG. The reason this is here is because it creates a new tunnel hybrid type that has both an underlay and the ability to tie it to the draft with color. As you saw in previous 110 and 109, what happens is the client routes are tagged with a tunnel type and a color, and this takes us into color-coded routes that we've seen in other drafts. And it has a description of new information in the tunnel types. So you see both the tunnel types with various security associations. My interaction with this draft started as I worked with several drafts regarding IPsec to try to get some common definition with a best draft, with another proposal for IPsec, and with this draft. The key point here is that you have to realize this tunnel type is for a particular use case with sub-TLVs that provide SA, so that you have, as you see in this previous things, both two types of paths depending on the security association. So folks, that's what the TLV is. That's the reason. The reason the draft has quite a bit of explanation is because it's difficult to tease apart the use case from the draft. So part of what the authors would like is this a good starting point for this draft? And do you think we should pull out any of the text? The draft itself with the essay underlays is fairly simple. You may have hybrid tunnels with different underlays. So I'm going to stop in interest of time on the underlays for the tunnel types. There's also a SAFI that fits with the color that provides information about the SD-WAN sites and colors. And again, this fits more in the color type NLRIs. So this draft has been under adoption. There seems to be some, as a working group member, there seems to be some strong interest because this use case is being deployed in multiple places. With that brief overlay, a different overlay than a description than Linda has given. Maybe it'll give some of you some insight into why we're looking at this. I'll take questions, and Kosik will help me answer any questions that I might miss, as he's actually doing some of the coding for the implementations. And Jeff, somehow the list screen has not worked for me. So I'll need help to determine if someone's requesting.
I will watch for that.
Okay. Okay, if there's no discussion on this, we'll consider our discussion closed. This draft has got several interests. CARE is the shepherd. Please send your comments to CARE. The authors would like to know, should this draft split the mechanisms and a description? There are descriptions adopted for SD-WAN case in BEST. If there's something that should be informational about the mechanisms, if you tell us that. If we see that there's lots of interest, again, that's with my individual contributors hat, with my taking off my individual contributors hat and putting on my IDR shepherd's hat. I'm interested to see if we can continue to follow up on the IPsec based work. The best work has not progressed rapidly in that area. There was a best draft based in EVPN, so that's where it is. We also had another IPsec without any other application. I look forward, if you have those drafts, as the chair trying to shepherd these through, to try to push this through. There are many, many implementations of IPsec in the internet, and as we switch to the tunnel attribute, I hope that people will come forward with them. And I've been trying to shepherd them along and find the use cases and see if we can take that through. That was my part of the tunnel draft when John and I divvied up the work. Any other questions for this interim? The next interim is on FlowSpec. It will occur, just a minute, so I can pull up the dates and not have my brain fail, will be on the 13th of September. And it will discuss FlowSpec. At that time, we'll take V2 FlowSpec draft. I've sent out discussions on that. I'll provide a presentation, and we'll provide presentations for all the drafts that are V2 capable. I look forward to that time. Jeff, Kara, anything else?
Nothing for me.
Kara?
Nothing from me as well. Thank you so much.
Okay. Anything else from the other participants? The chairs would like feedbacks if this longer presentation time helped. With that, we'll close the meeting.
Thank you, guys.
Thank you all.
Talk to everybody soon.